While we're waiting for everybody to filter in, I'm going to run a few minutes of review of some of the things we've covered. Let's first start out with, if I have a star that is visual magnitude 7, and I have another star that's only visual magnitude 2, which one is brighter? Good. It's 2. It's kind of reverse order. And I apologize. They didn't ask me to put them in a proper order. And everybody's been using this, that layout for who knows how long. But at any rate, good question, or good answers. Let's see. What are the things that are important if you want to go observing stars? What do you first need? Oh, or your eyes.
Nighttime.
Nighttime. How about cities? No light pollution. What else? Sometimes you need a good chair and warm clothing, but
No clouds.
like today. I apologize. I watched the weather coming in, and it was on all the weather channels, and they were saying it was going to like rain and thunder. They were saying we were going to get a couple inches of snow up in Evergreen where I live. We had flurries, but no couple inches of snow. But when we looked at it, I thought, let's be flexible and get a better night for our outdoor viewing. Hopefully that'll be next week. So, did everybody have success finding Stellarium and or the website for Telescopius? See a lot of heads nodding. Great. So we're set up. I'm going to run a slideshow briefly describing how these tools work and a possible approach of how to use them both. And then I'm going to rig in my laptop to do more demos and hopefully have you guys follow me along. How many are using laptops? And how many are on iPads? It's about half and half. Yeah. Yeah.
Request to wait 3 minutes.
We are. Yeah. This is just my preamble. I'm waiting till 7.
Android.
Android.
Not iPhone. Not iPhone. Samsung.
Well, were you able to find the software in your?
Usually.
Yeah. Good. Good. Remember to sign in, folks. Otherwise, you'll flunk the course. And your parents will be upset that you wasted their tuition money. Question?
Yeah. When I was looking for that software,
Yeah.
I've got an iPhone and an Apple computer,
Right.
and with the Stellarium, it said it wouldn't do it on the computer, but I was able to put it on my phone. Is it worth going out and buying a tablet?
I wouldn't buy a tablet. You have an Apple computer?
Yeah.
There is an Apple version of Stellarium.
It says it wouldn't put it on there.
It wouldn't?
Yeah, mine wouldn't go on my iPad either.
No, mine would go on my MacBook Air.
There's more than one version on the App Store.
Is that?
One for the computer and one for an iPad.
Well, I not only brought my laptop.
You can download it. I think the instructions are on the website. You can download it.
Stellarium.
Step back up here so it'll be on camera.
Oh, yeah. The main differences I would, while we're waiting to start here, the main difference between the programs on a laptop versus an iPad is the screens are a little bit slightly different. They have the same functions, but they're located in slightly different places. So I did bring an iPad. So I'll be able to answer questions. Where is it on an iPad? But I know there's definitely a Windows 64 version. I'm quite certain there's a version for Apple or a Macintosh or whatever they call them nowadays. But it's about 7, so
You ready?
I'm ready.
Like this?
What's this
This
one?
That's an extra. This is the one that's working.
I think I'll take the one that works.
Yep.
I have enough trouble. Let's see. We have a stool here, thank God. Okay, good evening to all. Can everybody hear me in the back? The sound system is working? Good. We are swapping module 4 to hopefully next week we'll have a little bit better weather. So tonight we're doing module number 5. And so this is where we are on the roadmap. Tonight we're going to discuss observation planning. Last week, or what we hope will, or excuse me, this one will be swapped around after this, hopefully. So our agenda tonight, previously we've learned that observability of astronomical objects requires both they be big enough, like a planet has to have some size and arc minutes that you can see, but additionally visual brightness. We've also talked about what astronomical objects are visible by the naked eye. Does anybody remember what was that break point in visual magnitude that you can? 6.5. Yes, 6.5. If it's above that, you can probably see it in the night sky, provided you're in a darker place than downtown Denver. Last week, we talked about how different optical devices work. We started with binoculars. We got to the various types of telescopes that are out there and what makes them see. What's most important in a telescope or binocular? The magnification or the field of view? Field of view. Yeah, you can, if you can't see it, or if you can see only a tiny piece of it, it doesn't help you. Field of view is very important. And I think one of the things that, I think we've joked about is you go to Walmart or Costco and you see this telescope and it says, oh, it's got 300 power magnification. And you kind of go, great. Should I buy it? And the answer is no. Well, we didn't try any devices out in the field, so that's yet to come. So tonight we are going to look at tools used in observation planning. I'm going to describe some suggested reference books. I've left a couple of them on the table. By the way, they're not for sale. I dearly love some of these. I I use them quite a bit. I've turned the corners on some of those pages so many times. I'm going to discuss a suggested astronomical website to look at, Telescopia's. If you're using a laptop, you access the tools over the website. If you have an iPad, you can download the program onto it. As a matter of fact, you can even download it onto your iPhone. I don't know if you can use that much of the functionality on a phone, but and then suggested planning software that you can download either on an iPad or on a laptop. Stellarium. Stellarium is a result of a project in France, believe it or not. It's pretty cool what it does. This is a recommended book. I've got a copy of it sitting on the back table. It's not expensive, $10. Maybe the price has gone up or down, I don't know. But it's got 50 objects that it suggests you can look at. It covers their size, their visual magnitude. It also covers the seasonal availability. In other words, is this an object you're only going to really be able to see in the winter versus the summer? And it's an excellent starting guide. So you don't need to write the title down. If you download the PDF version of my slides from the website, this is all in there. Turn Left at Orion is a classic on finding things in the night sky. What's interesting is one of the authors is the official Vatican astronomer. Do any of you guys know where the Vatican Observatory is? Dina, you're cheating. You know all of these. Do any of you guys know where the Vatican Observatory is? No, it's in Tucson. You couldn't see the night sky in downtown Rome or in the Vatican, but the Vatican maintains an observatory right up next to all the other big university and government funded observatories. But I met Guy Consolmagno. He's a Jesuit priest. He runs the observatory, and I guess he's been trying to educate the Pope that, the Earth is not the center of the universe, and that if you really open your eyes and, get a telescope, you'll see that it really isn't. Good book. It covers everything from how to use various types of telescopes, object size, magnitude, and he covers more than 100 galaxies. It's a very comprehensive book. It's about $34 on Amazon right now. $34.40 plus shipping, I guess. Another one that's possible, this is relatively inexpensive because it's not that big. Star Charts book. And it basically has, it's got a planisphere in it. Does anybody know what a planisphere is? We haven't discussed that in the previous stuff. It's basically a circular disc that you put in the date and rotate the thing around, and then you hold it up to the night sky, and it's going to show you what's visible in a particular time of the year and overnight. It's kind of a handy thing to have. And it comes with a glow-in-the-dark planisphere or star finder. But anyway, I've left copies of them in the back if you want to look at them. Like I say, the links to these books you can get them on Amazon. The slides are, from tonight's talk will be available for you to, to order them if you are so interested. Observation planning. Sometimes, and I do this myself, and I think a lot of people do it, you just go outside on a nice warm night, get in a lounge chair and look up and just see what is available. But actually, other times, it's desired to go out and look for a specific object. Like Steve Barr and I have been talking about stars with unusually low metal content and where to find them. And we found a couple, and they're on my bucket list for the summer to go look at them or try and look at them, and also to locate them, take photographs, and also develop a spectra, an optical spectra of those stars. So when you want to go out and look for something in specific, you're now involved in the world of observation planning. So the issues that you have to deal with: will a specific object be visible tonight? Remember, we've talked about the fact that we've got winter stars and we've got summer stars, and because of the obliquity of the Earth's rotation around the sun, in other words, it isn't like this, it's going around the sun at an angle of about a little more than 23 degrees. And what that gives us, it gives us seasons, but it also eliminates certain objects from view. So the first question is, what we're looking for, is it going to be visible tonight? When will it be visible? One of the things we have talked about a little bit before is that some of these star objects, stars, nebula, galaxies, they will rise and they will set as the Earth rotates. The next question obviously is where, and that's getting into azimuth and altitude. Do we have anybody in here that was in the military that was like an artilleryman? No. The key thing that guys that run big cannons and howitzers is azimuth. That means what direction, and altitude. What's the angle upwards? That's what we're going to be trying to do with a telescope or binoculars or even maybe your naked eye. But you need to have some source of information where to look for the object in the night sky. The majority of the software used in planning is based on what they call the J2000 EPIC database. This is a database of the locations of the stars fixed at midday on the spring equinox in Greenwich, England. Everything is relationship to that. That's like your 0 point. The planning software uses this J2000 database. And by the way, as an exercise once, I downloaded the whole thing so I could do sorts like what are the top 100 bright stars out of there. There are actually something like 212,000 entries in that database. Again, I mentioned the star positions are referenced to midday, spring equinox in Greenwich, England. It uses a term, right ascension. Has anybody heard that term before? I see some nodding. Dina, you're cheating us again. Right ascension is basically a measure on a 0 to 24 hour scale where how far the star is located from that midpoint, 0 degrees, Greenwich, England. In other words, here in Denver, Colorado, where, if I've got it right, we're about 7 hours behind that. So all calculations then have to be based on a standard, and that's what they're using. and it is a right ascension scale of 0 to 24 hours. Declination, that term basically is your elevation. It runs from 0 to 90 degrees on the northern hemisphere and 0 to minus 90 on the southern hemisphere. If I know from a database these two numbers for a star, I can compute where it will be any other time of the year. This is what the planning software does. The observer, you, with a laptop or something, input your latitude and longitude. That's used to figure out how far off you are in the right ascension scale. And then the time difference from where you're located from Greenwich. You take the J2000 database and software, and what it will produce for a specific time and specific observer location, the exact azimuth and altitude to locate a specific star. Does that make sense? Okay, the first tool I'm going to mention tonight is Telescopius. Telescopius is a web-based tool on a laptop, but they have a completely downloadable app that you can put on an iPad or even your phone, although I've never used the thing on my phone. One of the first things you notice here is where are you located? I've got here Colorado. This is not downtown Denver, by the way. This is right up next to my house, where my observatory is. For a given date, these slides I prepared a few months ago, it will show you the hours of daylight, nighttime, and then sunrise. So you get sunrise, sunset. This helps you figure out, am I wasting my time, or is it actually going to be visible? Back in February, the sunset was 5:33. Sunrise was about 6:58. They also have a term called astronomical night, which is basically a measure of, you're beyond the twilight. In other words, it's dark. View that as just kind of an indication. It's really dark at that point. They want you to make a small donation. I give them $5 or something, they'll be happy. It additionally contains, from your location information, a snapshot of the weather, which is kind of handy. It then consists, across the top, we've got targets. There's a toolbox, and I'm not going to get into the astrophotography part tonight. One of the features that I use quite frequently is the telescope simulator. And what that does is there's like a drop-down box, which I'll show you in a minute, that you take the information about your telescope. In other words, the focal length, the aperture size, what types of eyepieces you're using, and it will generate a picture of what you could see on a specific target. And I think that's a very helpful tool. Before I used Telescopius, to give you an example, I was in a dark area in Arizona. This was a few years ago. And I wanted to capture an image of the Rosette Nebula. And I have a go-to scope, and I set it up, polar aligned it, did all the good stuff, and said, take me to the Rosette Nebula. And it did. But there was one problem. I got the very center stars of the Rosette Nebula, and I couldn't even see the red glowing gases around it. If I had had a tool like this, I would have been able to say, if I'm going to try and image that thing, I'm going to have to take, a matrix of separate shots and try and stitch them together in Photoshop or something. But at any rate, the telescope simulator is a very valuable tool to help you understand what you will see in the field. So, okay, I've mentioned it's web-based. It allows a very quick selection of astronomical targets. In other words, it's going to give you a list of from where you are tonight and your location and time. These are some things you might want to consider taking a look at. That's why I think it's a very handy tool when you're getting into astronomy, because it kind of points the way to the good stuff in a hurry. It identifies the best times to try and observe the targets. Some of the targets will be up at night. Unfortunately, if they're up at 3 a.m. in the morning, I'm usually in bed, getting my well-deserved, nap time. But it will show you the windows that various objects are visible. It allows a visualization of what a specific telescope or binoculars will see in the night sky. The weaknesses. Well, first of all, most go-to telescopes that want right ascension and declination are typically found in go-to scopes. It does not allow you to, quickly get the azimuth and altitude and put it into a go-to scope. It requires internet access. So this is what I would characterize as a planning tool. That maybe in the afternoon before you're doing your your viewing, you go out and identify a couple of targets you want to look at. You evaluate whether you'll be able to see them. One weakness is planning for individual star viewing is a little weak. By that I mean, if I want to go look at T Corona Borealis, you'll have a hard time identifying it because this tool is mainly looking at planets, nebula, galaxies. And some of the galaxies are obviously clusters and things like that, but looking for an individual star is a little weak on this. To use it, you open the thing on the website and you create a free account. How many have tried that already? About 40% maybe, just eyeballing the crowd. The purpose of setting up a free account, you can store your wish list of targets. So maybe that target is not available tonight, but maybe in a month or so it will be, and it's got some of the data already stored there, so it has a wish list. It also stores your location. You have a default location to start from. In other words, if I go to Arizona again, I'm going to have to go into the thing and I'm going to have to change my present location. This is like where you start. You put your observatory settings as the first piece. You can insert observer latitude and longitude. How many of you have a smartphone with a compass function on it? I see a show of hands. Pretty much, I guess almost everybody. If you go to the compass function, you will find it spits out the latitude and longitude coordinates as a side thing while it's telling you, this is north and that's, east. It allows you to select specific types of targets via a drop-down box. There's targets. It's got constellations, planets, comets, asteroids, deep sky. This is where you keep your personal target lists. I don't know about all of you guys that have played around a little bit. There's some objects in the night sky that I like to go back and take a look at again and again and again. Andromeda, Pleiades, the Bode's galaxies, all of that. But you can create a list that helps you quickly get to them while you're using the tool. So basically you open up the toolbox, select target list. The other piece that's in here that's very useful, I mentioned, is a telescope simulator. What you do is typically, unless you've bought a Walmart telescope, there is a boilerplate tag on the telescope that identifies the focal length and the aperture of the main body. And with those two pieces of info plus the eyepiece, how many millimeters the eyepiece you have, it will allow you to simulate what you're going to see. This is an example. This is my home telescope. It's got a focal length of 900 millimeters, 100 millimeter aperture. I have a Barlow reducer on it, and it shows you what you're going to see if you were looking at this particular item. The right ascension and declination numbers are basically for using in a go-to telescope. When I have done this work, it will appear right down there. Target selection. I always like the Rosette Nebula, although the colors in this are not necessarily the ones I would expect to see. My bad example of poor planning when I went to Arizona a few years ago, what I was able to see with my telescope was originally like this. And I kept thinking, geez, where on earth is all of that wonderful red color in the Rosette Nebula? And the answer was I had to make some adjustments. If I put things in correctly, this thing shows I would be able to see the entire Rosette Nebula. The simulator will also help you rule out objects that you really can't see very well. I'll give you an example. Crab Nebula. Crab Nebula is also known as Messier number 1. This is all you would typically be able to see of the Crab Nebula. You won't see all the exotic blues and other things in there. Looking at one of the graphs that pops up when you start to go to a target selection, it shows you kind of the window of viewability. That's a handy tool. It'll tell you that I can do this after dinner, let it get dark, go out and maybe shoot this at 9 o'clock or 10 o'clock, but be done, be done early. I typically like targets that have that type of profile because I like my sleep. Oh, one of the other features right now, I've mentioned that the star database, J2000, not surprisingly, was put together and is accurate for the year 2000. Well, shucks, we're now in 2025. And there is an update, which goes by the name of J Now. And it's off a few degrees from what you saw in the J2000. But I'd look at both of them when I was planning an activity at night. When photographed, enlarged, or cropped, that's what the Crab Nebula, starts to look like. Problem is you have to really stretch the picture out, and you can't really see all the glorious colors that the Hubble Space Telescope found. But it does give you a pretty good visualization of what you can see and what you or expect to see when you're out there in the field with your equipment. So I was going to do some practical exercises, but I've concluded we'll do them after the slide presentation. And I put my own laptop up here and we'll try and walk through them, and I will display them rather than trying to do it. But what I would like to have you consider is, okay, given today's date, what's a good nebula target to look for tonight? And I'd like you to think about inserting your own telescope or binocular specifications into the telescope simulation, and also try simulate viewing M45, which is the Pleiades cluster, Seven Sisters. And then I'd like to also have you try out, or we will try out, the effects of switching eyepieces from the typical 25 millimeter eyepiece down to the 10 millimeter eyepiece. I'm now going to jump into the other tool, which is called Stellarium. This is a screenshot of a Stellarium output. It's got the Whirlpool Galaxy in there, which is M51. And a typical display screen when you've loaded it up, and I will show you in a minute how you load the parts in. It's got the azimuth and altitude. I got to make this pointer work. Oh, there it is. I got it. Altitude and azimuth is right here. The right ascension, declination of a specific star is there. It's got the magnitude. There's our visible magnitude. And it's got a lot of other, useful stuff in it. Again, it's got the opportunity to use what we call J Now. How it works. Stellarium is free software, and it works for Windows, and there are iPad and iPhone versions also available. It can be run with or without internet access, which means you can use it in the field, like on your phone or an iPad. It provides very detailed azimuth, altitude versus time headings. And one of the things you can do with Stellarium is you can pick an object and then adjust the time, like, let the time go every 10 minutes or every half hour. And you can watch where an object will track over the night sky while you're simulating it. Like Telescopius, it also contains a telescope simulator. Weaknesses. The main one, oops, who's trying to reach me now? The weaknesses in the field, as I think I showed you in that graph, azimuth and altitude are pretty darn hard to read in the field, particularly if you have placed a red screen over your laptop or iPad to prevent it from, blotting out the light of your fellows that are out with you. This is what it looks like on a laptop when you open it. And like I'd say, surprise, surprise, they developed it in France, so you get the French countryside as the background. It does have options to do things like, well, I'd like to change it to Utah or something like that. I never do that. I'm more interested in what's in the sky than what's on the ground. But it's just basically to have a horizon reference. In Windows, oops. When you open it up, I gotta get used to using this pointer. Right here is, a little, looks like a kind of a stopwatch, but this is your quit and exit button. The other one that's very handy and useful is this guy right here, which expands the display to the width of your laptop. Oops, go back. Right in here is this arrow going forward. This is what you control the speed of time changing while you're watching the display. And they have a lot of other cool stuff that I don't necessarily use, like you can have it display the historical Greek names of the galaxies and constellations. I don't use that much myself. Okay. To change the location of the observer, it's the same kind of thing that you're going to have in any program that's doing planning. This compass rose here is where you input your location. Right here, the clock is where you input date and time. Right down here, the magnifying glass, this is where you input a name of something. Stellarium takes Messier number designations, NGC or New General Catalog numbers. It takes, in a lot of cases, common street names for things like Pleiades. You don't need to know what Messier number it is. The only weakness with this thing is that you will find some stars have like up to 7 or 8 different names. They've got the English version, they've got the Arabic version. But at any rate, this is where you search for a specific object in the sky. First step is when you get into it, using the compass here, you've got to input where you are. For tonight, I would just say we're in Denver. And that happens to be a drop-down list of all kinds of places. So you could even use this in Algeria or Kazakhstan. But at any rate, your options are to select a city name that you're close to, or to go through the effort of inputting latitude and longitude values. So I mentioned earlier there's two ways to get the data. You got a location dialog. You can use a GPS. If you have the compass function on your smartphone, that's a source for it. Maybe you have a Garmin with you. Okay, some exercises we will do when I finish the slides is we're going to go into the location box in Stellarium and switch us from Denver to Tucson, Arizona. And then we're going to change it to this location. I just want to get you used to how you use the tool before you have to go there. The time and date dialog. When I hit this, I will get a calendar, a year, month, date, and then I will get on a 24-hour scale, the time. One of the features that's kind of interesting with Stellarium is that when I open the date and time dialog, it allows you to change to any date in the past. And I remember in, I think it was December 21 or 22, where they had the conjunction of Jupiter and Saturn. They were very close to each other, and with one picture you could get both of them all in one. And people were trying this and saying, well, why don't we go back to Christmas Eve in the year in the year 0, and can we see the Star of Bethlehem? Well, that doesn't work. The reason is, and I'm here in the secular hub, so people will probably immediately say, the Bible didn't actually say the exact date of the birth of Christ. My Jesuit friend who runs the observatory down in Tucson said, if you read the Bible carefully, it points out that the shepherds were in their fields at night, and it was very cold, but they were there watching newborn lambs. Well, newborn lambs don't appear at Christmas Day or Christmas Eve. They're in the spring. And so the date is just insane, but they couldn't identify with Stellarium what was the quote Star of Bethlehem, if it ever existed. But what you can do is go back and look at past events, like an eclipse that happened a year ago, or the one in what was it? It was 2017 in August.
Does that work for comments?
Pardon?
Does that work for comments?
Yeah, it does work for comets. One of the problems with comets, though, is that sometimes they don't get into the database. The big ones, that have been around, like 2021 Leonard, and I think, what was it? ZTF, or what was it? I can't remember the exact year number. I think it was 2023 ZTF. Some of those big ones, they're there, you can find them. Otherwise, you're on your own. But one of the things that I would suggest as an exercise how to learn this is to put in a date and our location in Denver, and run oops, keep doing the wrong button on this guy. Run the time back and forward and see what happens. You can watch the sun rise and set, the moon come up, the various stars and, astronomical objects. What you will see is they have a tendency to arc around with the passage of time. The viewing dialogue, there's a lot of things you can do to, arrange your screen. I tend to be very simple. I'm not interested in, putting up landscape changes and whatnot. If you are so interested, I'd say take it home and play with it. I usually just use the stereographic. This is how you open the search dialog with the kind of your magnifying glass. The telescope simulator is found, see the monkey wrench up here? This opens the simulator, and what's really cool about Stellarium is it's got all of the big names and telescopes represented here. And you can basically scan through it with a slider bar. Make sure it's got the right focal length and diameter and whatnot. And an interesting exercise, Orion, is to go search for a big, well-known star like Betelgeuse. Now remember, this was set up, when I did this was a few years ago, but here's your azimuth and altitude apparent. There's the star you're looking for. One of the things you can do with Stellarium is you can take your cursor, your mouse, or I guess your finger if you're doing it on an iPad, and go to a specific star, like Procyon, and just tap it, and it will automatically adjust this thing to the new star. Sometimes that's a nuisance, I will tell you. Because you're trying to study something and maybe you're trying to move the entire screen in one direction. So a summary, I've mentioned some books that give you an idea where to look, and they're in the back of the room. If you've got a computerized go-to telescope, Telescopius is a good place to start. If you're using an alt-as telescope, like with a fork, and you can rotate around and do that, Stellarium is pretty quick. I will tell you how I tend to use it. I use Telescopius for quick visibility checking. In other words, is it going to be visible tonight in my neighborhood? And if it is, then I use Stellarium for the detailed planning. But I get a quick read from Telescopius that it's going to be visible in what hours. And it gives me, it's that graph that shows the bars and two sides and how the object arcs through the sky. So when you are using these tools and you have an idea you want to look at a specific object, I recommend very strongly that you keep a planning and observing notebook. And when we get to our outdoor session, I'll bring one of my old ones. But the things you keep in there, what did you look for on a particular night? Where was it? When did it become visible? What level of detail could you see with your equipment? The other things that I keep in an observing notebook is like settings. I actually, on my refractor telescope, have taken a magic marker on the extension tube and drawn a line all the way around. Where is the focus point for infinity? And things like that are handy to know when you're trying to set it up in a hurry. Like I know the number was like 11.4 centimeters. I have to have my extension tube drawn to get to focus at infinity.